Student, today we will learn the chapter Maxima and Minima. As in the previous part, we have already learned so many things about application also. In this part we will do some more questions for plane geometry and for solid geometry. Okay. You know the area of the triangle, square, quad, circle, and you know the volume and surface, cube, cuboid, cylinder, cone. Okay, if you don't know these all formulas, you should be go first mensuration chapters, plane and solid mensuration, so that you can understand this type of the question. Now I will do 2-3 questions here. A window is in the form of a rectangle surmounted by a semicircle. If the perimeter be 30 meters, find the dimension so that the greatest possible amount of light may be admitted. Student, first you have to read the questions carefully. A window is in the form of a rectangle surmounted by a semicircle. If the perimeter is 30 meters, find the dimensions so that the greatest possible amount of the light may be admitted. So according to these questions, first we have to draw a diagram. Last here is a window. This one is a rectangle form and this one is a semicircle. Okay. So light will become through this. Light will become through this. So we have to find the dimensions so that maximum light amount of light may be admitted, maximum possible light, greatest. So maximum area of this figure we have to find out, and perimeter of this will be given in the questions. Okay, so understanding this topic, then we can go that in the figure, let it is A point, B point, and C, D, let it is Y, and it is let 2x, so that it is x, it is x, it is x. X is the radius of semicircle. Okay, total length is 2x and breadth is y. We can take it. So perimeter is 2x plus this one plus this one plus this one. This one is your perimeter according to figure. Okay. Let dimensions of window length equal to 2x, breadth equal to y of rectangle, and radius of semicircle equal to x, right, in centimeters. And now it is given in the question that the perimeter equal to 30 centimeter. Perimeter we can take here, that is y plus 2x plus y, and this arc. Okay, so y plus 2x plus y, and length of the arc, that is half of circumference 2 pi r, is equal to 30. So now we can see this one is your equation in terms of x and y. Okay, now area we have to find for maximum. So area equal to, we can say, area of rectangle plus area of semicircle. And you can understand the greatest amount of light comes from window means area, you have to find the maximum. Okay, so 2x into length into breadth. Okay, area of semicircle is half pi r square. Right, now these equations we have to change in one variable with the help of these equations. Right, this equation 1, with the help of this equation we have to change in one variable. So what is the easier to change it in terms of, we are going to change it in terms of y. So we are putting the value of y is 30 minus 2x minus pi x plus half pi x square. Now it is in terms of x. Okay, open this bracket, we can get 30 let me check it. Value of y is 30 minus 2x minus pi x upon 2 upon 2. Now open this bracket, 30x minus 2x square minus pi x square plus half pi x square, and 30x minus 2x square plus this one is minus half pi x square. Now we can go to find dA by dx. 30 into 1 minus 4x minus half pi into 2x. Now using this we have to find dy by dx equal to 0. So we get 30 minus 4x minus pi x equal to 0. Hence we got x equal to 30 upon pi plus 4. Now d2y by dx square is, we have to find it, that is we are getting 0 minus 4 into 1 minus pi into 1. Okay, equal to minus 4 minus pi at x equal to 30 upon pi plus 4, it is equal to negative. Okay, putting this value here, x to the power 0 here. Okay, so it is negative, putting this value. Hence we can say area is maximum at x equal to 30 upon pi plus 4. Now we want to find the value of y. Hence using the previous equation, 2y equal to 30 minus 2 plus pi x, putting value of x here, we can get 30 minus 2 pi plus 2 plus pi x is here 30 upon pi plus 4, and solve it. What we get here, taking the LCM, and then we can solve it. So we get 30 pi plus 120 minus 60 minus pi into 30 upon pi plus 4. So we can see here 30 pi is cancelled and here 60. So what we left here, 2y equal to 60 upon pi plus 4, hence y equal to 30 upon pi plus 4. Hence for maximum area x equal to y equal to, both are 30 upon pi plus 4 meter. Now in the question it is given that find the dimensions, hence length 2x is equal to 60 upon pi plus 4, breadth y is equal to 30 upon pi plus 4, and radius equal to x equal to 30 upon pi plus 4 meter. Okay, so this is your required answer to find the maximum amount of area, right? This way you can solve the questions. Now I am explaining one questions for 3 dimensions, means solid mensurations. So take one questions. Find the radius of the closed cylinder closed cylindrical can which is right circular, okay, which enclose is given volume of 100 centimeter cube, it means volume is constant, and has the minimum surface area. So student, in a cylinder, this one is radius, this one is height, okay, and volume is given constant. So volume equal to constant equal to 100 centimeter cube. You know the formula, pi r square h. So it is your first equation. As I already told, one equation should be with constant and second should be for maximum or minimum. Now total surface area, you know the formula, that S equal to curved surface plus top and base 2 pi r square. Okay, it is solid, so this one is your total surface area. Now these two equation we have to change using this in any one constant. Let we want to be change using h 100 upon pi r square, putting here, that will be easier to change in value of r here. So what is the easy that you have to decide. Okay, so s equal to 2 pi r, putting h equal to 100 upon pi r square plus 2 pi r square. This you should be decided yourself which variable you have to take here, h or r. That will be easy that you think yourself. Okay, so now pi is cancelled, 1 r is cancelled, so there is 200 upon r, and here is plus 2 pi r square. So we can say s equal to 200 upon r plus 2 pi r square. This is your required equation. Now ds by dr, taking this minus 1 r to the power minus 2 plus 2 pi into 2r. So we can write minus 200 upon r square plus 4 pi r. Now according to formula we have to keep it 0, so we can take minus 200 upon r square plus 4 pi r equal to 0. So from this we have to find the value of r. So what we have to find the value of r here? 4 pi r equal to 200 upon r square, so that r cube equal to 4 is cancelled here, 50 upon pi, hence r equal to 50 upon pi, taking cube root power 1 by 3. So at r equal to this we have to judge the d2. Now taking the d2 of this, what we got it? d2s by dr square is minus 200 into minus 2 r to the power minus 2 minus 1 plus 4 pi. You can see here again, taking r to the power minus 2, then differentiate, r is 1. So we can find it 400 upon r cube plus 4 pi. Okay, now at r equal to 50 upon pi to the power 1 by 3, putting here, we can find 400 upon 50 upon pi plus 4 pi, and that is greater than 0, means positive. Hence s is minimum. Okay student, so we can say, and s is minimum, so we have to take the find the radius at these conditions when s is minimum. So we can say, since r cube equal to 50 upon pi, therefore we can find it using the equation of volume, that is h equal to 100 upon pi r square, putting here r cube, value of r is pi, that is 50 upon pi to the power 1 by 3, here is 2 also, so they are 2 by 3. Okay, and after solving this we can get it 100 upon pi, and this one is we can get we can write this way, that this one is 2 into 50 to the power 1, okay, upon pi, and this one is 50 upon pi to the power 2 by 3. Taking this calculation, 2 upon pi, 50 upon pi to the power 1 minus 2 by 3, that is 1 by 3. Okay, so so now we can say it is 2r. Okay, so h is twice of radius, where radius equal to 50 upon pi to the power 1 by 3 in centimeter. This is your dimensions. Okay, so this is your required answer. Now this way, student, you can solve so many questions about cylinder, cone and other solid things. Right, student? One more question I want to explain you. Show that the semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse root 2. So according to question, in this here L is given, that is constant, that is R variable, that is H variable. Semi-vertical angle of the cone is this one, that alpha. Okay, so for maximum volume, to prove alpha equal to tan inverse root 2, L is given, that is constant. Okay, so volume equal to 1 by 3 pi r square h. Right, so volume we have to find maximum when L is constant, so we have to change here some value so that we can find the L here using the constant L. Right, so we can write it that R square is changing here, L square minus H square into H. Using the Pythagoras theorem, L square equal to H square plus R square. Now L is constant, so we can see L square upon 3H minus H cube upon 3. Now dV by dH, we can take L square by 3 into 1 minus 3H square by 3. So L square by 3 minus H square. Now dV by dH equal to 0. So we can put L square by 3 minus H square. L square by 3 minus H square equal to 0. So we can find value of H L upon root 3. Now d2 V by dH square we can find here, that is differential of this 0 minus 2H minus 0 minus 2H equal to minus 2H at H equal to L by root 3 d2 V by dH square is minus 2 into L by root 3 equal to negative, hence volume is maximum at H equal to L by root 3. Therefore, we can find the value of R, that is under root L square minus H square. So L square minus L square by H square is L square by 3. So we can get L R equal to under root that is 2L square by 3 equal to L root 2 by root 3. Hence tan alpha equal to, in the figure, perpendicular upon base, that is R upon H. R is L root 2 upon root 3. H is L upon root 3, that is root 2. Hence alpha equal to tan inverse root 2 for maximum volume. Proved. Okay, so student, this way you can calculate so many questions. You should be use the algebraic equations. Don't try to be more use of trigonometrical equations, so that calculation will be easy for you. Okay, now thank you for watching, and I hope this all parts will be helpful to understand the chapters maximum and minima. Thank you for watching.